Okay, hello physical science, this is Mr. B, and we are going to continue on with Chapter 1, and we are now moving on to Section 2, which is entitled Using a Scientific Approach. And what we're going to encounter in this chapter is what we need to do as scientists once we encounter a problem, once we find a question that we want to know the answer to. How do we go about doing it correctly and as what they call here the scientific approach? And the example that they're actually going to start us out with on how to use a scientific approach is a good one. It's a really interesting question. So the question, or kind of the scenario is that you are caught in the rain and should you run or walk? Maybe you should run, which would mean less time in the rain, which means less water falls down on you. Maybe, however, you should walk, moving slower causes you to run into fewer drops. This is a question that you can try to answer with a scientific approach. Now this is, again, that's a pretty simple question that you've probably encountered before, but you've never really sat down and thought, well, how can I figure out which one is better? Should I run or should I walk? So right now in your paper, maybe just jot down what you think would be better. Are you going to be drier if you run through the rain, or are you going to be drier if you walk? So we're going to use a scientific approach, or we're going to look at an example of someone that used a scientific approach to figure that out. And they use their scientific approach in something called the scientific method. So that is a really big term here that encompasses a lot of different things, the scientific method. And first we're going to look at, again, what is the goal of the scientific method? What is the purpose of it? So again, first though, we're going to actually get our definition of the scientific method, and it is an organized plan for gathering, organizing, and communicating information. So this is a really, really important term. Again, I would definitely jot this one down right here. And we can use this scientific method to answer a question, and it can vary from case to case depending on the question and how the researcher decides to look for an answer. So here in a second, we're going to get kind of the main overline or kind of outline of how the scientific method can occur. Like I said, some scientists are going to do things different ways depending on the case, but for the most part, it's going to be a pretty orderly step-by-step process that we can follow. And by following it, our goal is going to be to solve a problem or to better understand an observed event. So that is, again, the big thing with science. Again, we have to be curious to start off. However, then, after we're curious, we should be presented with some type of question or problem that we can solve, and that's when we bring in the scientific method. And so here, if we look here over on the right, we're going to see the example of the scientific method, and each one, we're kind of going to add one step by step here. And again, like I said, the order of the steps can vary, and sometimes you use all the steps and other times only some of them. So this is not a universally perfect system, but for the most part, you're going to use all of these, if not, or if only some of these, when you're taking a scientific approach. So the first step, if you look over there on the right, is to make an observation. So you're always going to start by making an observation. You have to see something to begin with, and again, it could be the rain, and you need to figure out kind of what I'm going to need to do next. Next one is asking a question, and we're going to get more in depth with these. I'm just going to go through them quickly here. Each one will get their own slide. And then we develop a hypothesis. We test our hypothesis with an experiment. We analyze our data and draw conclusions. And after that, two options. We have either our hypothesis is supported or our hypothesis is not supported. And then if it is supported, then we still need to test with further experiments, because we can't really just accept it after one correct answer, and we have to test it again. However, if it's not supported, we don't give up. We go back and we revise our hypothesis, and we try again. So now we're going to break down each one of those a little bit more. Our first one, our scientific method, is making observations. So any scientific investigation often begins with an observation, and it is just information that you obtain through your senses. Something you hear, something you see, something you touch, something you taste, all can be considered an observation. So you see, again, our example might be Isaac Newton. He felt the apple fall off of the tree and hit him in the head. Again, that is how the story goes. So that is his observation and his hypothesis. He said that some type of force made that apple fall. So a hypothesis, again, you might have heard this would be like an educated guess. We can no longer use that. Hypothesis now is just our proposed answer to to a question. So anytime we think of a hypothesis, it's just our answer to a question. Again, most of the time, it's probably not even going to end up being right. So now we can test our hypothesis. So in an experiment, any factor that can change is called a variable. So a variable, that's a big word, and I'll probably have to go over this more in class, but people do get confused by that. But any factor that can change in our experiment has that term. And we have a manipulated variable, which is the thing that we are controlling, which causes the change, which again, I'll give you more examples of that in class. The responding variable, which changes in response to the manipulated variable. So really quickly, a manipulated variable would be if we're testing, again, maybe how plants grow, and we just want to look at the sunlight, so we manipulate how much sun we get, and we leave everything else the same, and the responding variable would be how much the plant has grown. And then when we put those two things together, the manipulated and the responding variable, we have what's called a controlled experiment, and that is an experiment in which only one variable, which is the manipulated one, is deliberately changed at a time. And that might not make a ton of sense to you at the moment. I know it does get a little confusing, but we do have an example here towards the end that will actually give us real life things that we can associate with the manipulated variable, the responding variable, and the controlled experiment. But I'd at least have some form of these three things here jotted down, so make sure you have those. So then we're going to go to our next step, which is draw a conclusion. So a conclusion describes how facts apply to a hypothesis. So we either draw a conclusion that we were correct, or we draw a conclusion that we were wrong, and then we kind of have to continue accordingly from there. And if we do get proven correct enough, we can develop what is called a theory. So a scientific theory is a well-tested explanation for a set of observations or experimental results. So once a hypothesis has been supported in repeated experiments, scientists can begin to develop a theory. So again, this is not just going to be something that occurs after one experiment. We can't run one experiment and then say that we have a theory, because it has to be supported with repeated experiments, even with probably different experiments that give us the same results in order for us to actually want to call that a theory and to actually be correct. So now we're going to give our example here of our scientific method, and as always, it is going to start with a question. So again, we're going to go back to the question that we had at the beginning, and that question is, how does speed affect how wet you get in the rain? So that is the question. Again, are we going to be more dry afterwards if we walk or if we run? So our hypothesis, again, that was in this experiment, was the faster the speed, the drier you will stay. Which again, that doesn't have to be your hypothesis. Just because you're wrong, it doesn't really matter. But again, there's a good chance that this is going to be wrong depending on how the experiment goes. And so our experiment is we test whether speed affects how wet you get in the rain. And so in 1997, 2 meteorologists actually conducted this controlled experiment to determine if moving faster keeps you drier in the rain. So one scientist walked 100 yards and the other ran the same distance. So they were outside, it was raining, they had a distance of 100 yards, and the only difference between the two of them is that one walked and the other ran. And so the variables, such as types of clothes, were controlled, and that meant that they both had the same type of clothes on. There was no differences there. And so the clothes of the walking scientist, he accumulated 217 grams of water, and the clothes of the running scientist accumulated 130 grams of water. So based off that conclusion, the scientists decided that running in the rain keeps you drier. So again, they followed a very specific set of rules and instructions, and they came up with a definitive conclusion based off their data that if you ran in the rain, it actually does keep you drier. So you can keep that in mind the next time you're outside while it's raining. So looks like we're up over 9 minutes now, so we're going to go ahead and call this one quits. Let me know if you have any questions.